Ever pondered over the inner workings of servo motors in industrial control? Today, we'll unravel this marvel of technology, dissecting it layer by layer to understand its operation. At its core, a servo motor is a rotary or linear actuator that allows for precise control of angular or linear position, velocity, and acceleration. It comprises a suitable motor coupled to a sensor for position feedback. This assembly, in turn, is controlled by a servo mechanism, a special type of feedback control system, where the output is controlled by varying the input. Firstly, let's clarify the main components involved in the operation of a servo motor. These include the control circuit, the servo motor, and the output shaft. The control circuit is the brain of the operation, receiving instructions and commands about the desired position. The servo motor, the powerhouse of the system, is responsible for producing motion in response to these commands. The output shaft, attached to the servo motor, moves to the desired position. Now, imagine a scenario where the control circuit receives a command for a specific position. The command, in the form of an electrical signal, is sent to the servo motor. As the motor starts to rotate, the output shaft begins to move. But how does the system know when to stop? Here's where the magic happens. Attached to the output shaft is a sensor, often a potentiometer, that monitors the current position. As the shaft moves, the sensor sends feedback to the control circuit, indicating the current position. Now, the control circuit compares the desired position and the current position. If there's a difference, it sends a command to the servo motor to continue moving until the desired position is reached. Once the current position matches the desired position, the control circuit stops sending commands and the servo motor halts. In essence, the servo motor's operation is a constant loop of command and feedback, ensuring precise control over the position of the output shaft. This precision is what makes servo motors an integral part of industrial control, used in robotics, CNC machinery, automated manufacturing, and more. To summarize, a servo motor in industrial control works through a combination of a control circuit, a motor, and a position sensor. The control circuit sends a command for a desired position to the motor. As the motor rotates the output shaft, the sensor monitors the current position and sends feedback to the control circuit. The control circuit compares the desired and current positions and adjusts the motor's motion accordingly, ensuring precise control of the output shaft's position. So next time you see a robotic arm perfectly picking and placing an object, remember the humble servo motor, tirelessly following commands and feedbacks, making the magic happen.